Ellipse is one of the conic sections that you have in a syllabus. In fact, in 2D coordinate geometry, you have 5 conic sections. That is, pair of straight lines, circle, parabola, ellipse, and hyperbola. Now they have removed pair of straight lines from your syllabus, so you are left with only 4. That is your circles, parabola, ellipse, and hyperbola. Right now, I'm discussing ellipse with all of you. Now, all these curves are 2D curves, whether it's circle, parabola, ellipse, or hyperbola. So or you can say a plane curve. So over a given plane, you will have a moving point, right? And the point will move under a fixed geometrical condition. So the path traced out by the moving point under the given geometrical condition will give you the locus. So the locus can result into an ellipse or a parabola or ellipse or hyperbola or circle, depending upon the condition that is imposed over the moving point. Like in case of ellipse, let's see how we impose the condition over the moving point. You will be given with a fixed point and a fixed straight line. The fixed point we call as focus and the fixed straight line we call as directrix. This moving point will be imposed with a condition, geometrical condition. That is, this point is allowed to move over this plane, but under a fixed geometrical condition. What is that? It is the ratio of the distance of this point from this fixed point and its perpendicular distance from a fixed straight line. This ratio will always be a constant, and this constant is always less than 1, half, 1 by root 2, 1 by root 3. So under this geometrical condition, the path traced out by this point will give an ellipse. How you find the equation of this ellipse? We take this point as h comma k and we write the geometrical condition P is equals to E times of Pm, and then we solve, and then we replace h comma k with x and y. We get the equation of the ellipse. So we need 3 things, right, in order to get the equation of the ellipse. That is, equation of directrix, coordinates of the focus, and the eccentricity. If we know 3 things, definitely we can find out the equation of the ellipse. Now, what do you mean by standard equation of ellipse? See, in case of standard equation of, whether it is a case of circle or parabola or ellipse or hyperbola, we always predefine origin. Now, what do you mean by predefining an origin? Let's try to understand this. We'll first mark the axis of the conic. Like in this case, we will mark like this. The axis is always a line which passes through the focus and perpendicular directrix. So we'll get this axis. Now on this axis, we'll try to search point or points will satisfy the given condition of ellipse. Like in this case, Ps by Pm is E is less than 1. So we can take half. So let's say for half, we'll have a point here which will internally divide this segment, the ratio 2:1. So this is a point which will lie on the ellipse if E value is half. But then you can have one more point on the other side, right? Here also we can divide externally this line segment Zs prime into 2:1, 2:4, that is 1:2. So for a given E, since it is less than 1, we'll have 2 points on the axis, which satisfy the given condition of ellipse. Now, we'll take the length of this segment as 2a. Now we'll take the perpendicular bisector of it as y-axis. This axis will take x-axis. So we have predefined the origin here now. Now with respect to this origin, choice of origin, and these parameters of a and e, we can write the coordinates of s prime and this equation of the directrix. This will get as minus of a comma 0. This will get as minus of a by e. So now we got the focus, we got the directrix equation. So we can use this geometrical condition, and we'll use the distance formula and the perpendicular distance formula, and we'll transform the equation h and k with x and y. We'll get something like this: x square by a square plus y square b square equals to 1, with b square equals to a square 1 minus c square. And we'll have a step-while derivation where you'll find that if I replace the focus coordinate with plus ae comma 0 instead of minus ae comma 0, and equation of directrix with x equals to plus a by e instead of x equals to minus a by e, we'll find that we'll get the same equation. We'll get back the same equation. It means what? An ellipse is going to have 2 foci and 2 directrices. Now, The standard equation of an ellipse will be always of this format: x square by a square plus y square b square equals to 1. Means the center of this is at origin 0, 0. But again, we have two subcases for this particular standard form. When this a square is greater than b square and when b square is greater than a square. Whenever a square, the number below is x square, is greater than the number below y square, you will get horizontal ellipse. And if b square is greater than a square, or b is greater than a, you will get a vertical ellipse. Now, whichever is small, like in this case, b is smaller, so we write b square equals to a square 1 minus e square. E is less than 1, right? So we are multiplying a square with a fraction to get b square. This is how we can remember this relation. Here, what is smaller? A is smaller, so we can write a square equals to b square 1 minus e square. So if we rearrange the term, we will get e equals to what? Root of 1 minus b by a the whole square. Now, one thing we can understand from here, if we want to calculate e, so just we need to find the ratio of a by b or b by a. And if we know b by a ratio, we can calculate e. This is very important to understand from this equation. Now, how you trace, how you draw the graph. See, you have x square by a square plus y square b square equals to 1. You have only even powers of x. Means what? The graph is symmetrical about the y-axis. You have only even powers of y. It means what? You have the graph is symmetrical about the x-axis. So the graph is symmetrical about both the coordinate axes. So if we know the graph of only one, if we know the graph only in one quadrant, we can just fold it to generate the entire curve. So the graph is like this, or ellipse. For horizontal ellipse, for vertical ellipse, you have like this. You should clearly understand these points, coordinates. Like for a comma 0, minus a comma 0, 0 comma b, 0 comma minus b, foci is a comma 0, minus a comma 0, x equals to plus a by e, x equals to minus b by e. In this case, everything will get transformed on the y-axis, and x will get transformed to y. So this will x equals to plus a by will become y equals to plus b by e, y equals to minus b by e, 0 comma by 0 comma minus b. Now there's a very fast method of converting the translated ellipse into standard format. How we do that? See, whatever is multiplied with x square, that is your b square. So b square is 9 and a square is 4. So obviously it's a vertical ellipse. You can identify, you can get to know from here itself. Next, how you get the center coordinate? Just solve dou x by dou x, dou s, dou s. This way I call a second degree equation, the second degree expression. Partially differentiate this with respect to s equal to 0. Partially differentiate this with respect to y equal to 0. So when we solve, partially means what? When I partially differentiate with respect to x means what? I'm taking y as constant. So when I do that, see, 9x square will give you 18x, and this will give you 0. This will give you minus 7, this will give you 0. So we'll solve, we'll get x equals to 4. And with respect to y, this is 0, this is 0, this is 0. So I will get only y equals 0. It means what? The new center, the new origin is 4, 0. We already know the value of a square, b square. So this is what we have, x minus of 4 the whole square upon a square, y minus 0 the whole square upon b square. So we got the translated ellipse. Now, next. So in an ellipse, you should always know these two terms here. These two important concepts, that is concept of lattice sectum and concept of focal distances. See, you have a straight line passing through the focus and perpendicular to axis is called lattice sectum. So you can have two. You will have two lattice sectums here, one here and one here. The equation of this will be what? X equals to plus a. This will be x equals to minus a. Now this plus ae and the given equation can be solved to get the coordinates of L and L prime. So get the coordinates of L and L prime will come out to be a comma. It will come out to b a comma b square by a, and this will be a comma minus b square by. So what is the total length? 2b square by a. This is the length of the lattice sectum, 2b square by a. And one more very important property here. If you add the distances of this point from the two foci, it will be always a constant. PS plus PS prime will be always equal to the length of the major axis. We can prove it very fast here. See, PS by PM is E. PS prime by PM prime is also E. So what is PS plus PS prime? E times of PM plus PM prime. What is that? 2A by E. So we'll get cancelled 2A, hence blue. So this is also an alternative definition of ellipse. You can take two fixed points. You can take a thread. You can keep the thread loose in the beginning, and then keep the thread tight. Keeping the thread tight, you can move your pencil, needle of the pencil. You'll find that the path traced out will be an ellipse. So the definition of ellipse can be like this. It is the locus of a point such that the sum of distances of the point from two fixed points is always a constant. This is how we can define an ellipse. The distance is nothing but the length of the major axis. The fixed distance, the sum of the fixed distance, the fixed sum of the distances is nothing but the 2a value, that's the major axis. Now, if you want a line y equals to mx plus c to be a tangent on this ellipse, so you put this y here, you will get a quiet tick in x. Put the discriminant of this to be 0. This is the condition you will get. So y equals to mx plus minus root of a square m square plus b square will be the equation of tangent for a given slope m. Now, for a given slope m, what do you find here? You have a slope m for which you have a tangent. You can write one of the tangents like this. You can have one more. If you translate it here, you will get one more tangent. I'm considering only one of the tangents at this moment. Now you make this tangent to pass through h comma k. So I will transfer here. I will put h comma k and square. So we can see we are getting quite thick in m. Means what? In this given point, you can draw two tangents. Right? Now, if the angle between these two tangents is 90, means what? The product of the slopes is what? 90. So the locus of the points from where a pair of perpendicular tangents can be drawn to the ellipse is called as what? Directrix or directrix circle, sorry. You can see the locus will come out to a circle in this case. So if I put m1 into m2 equals to minus 1, c by a, you replace h comma k with x and y, you will get x square plus y square equals a square plus b square. This is basically a circle. So if you have an ellipse here, this is the ellipse that we have. X square by a square plus y square b square equals to 1. You can always draw a circle for it. X square plus y square equals to a square plus b square. This is a circle. So from here, if you take any point and draw two tangents on this circle, on this ellipse, sorry, what will happen? The angle between them will be 90 degrees. You take any point on this circle and draw tangents to the ellipse, you'll find that the angle is 90. This is the meaning of directrix circle. Now let's try to understand the parametric coordinates of an ellipse. Let's say we will understand this. We will take this as diameter and we will draw a circle. Now, if we take any point on the circle, let's say from here to the radius is a, this angle is theta. So we can write the coordinates as what? A cos theta comma a sin theta. So now drop an ordinate from it. This coordinate will be a cos theta only. So the other coordinate will be b sin theta. So any point on the ellipse can be taken as what? X equals to a cos theta and y equals to b sin theta. So now you can see here that this theta, what you have in the diagram, is called as eccentric angle of the ellipse. You can see here, if we eliminate theta here, if I write x by a equals to cos theta, y by b equals sin theta, square and that, I'll get back the ellipse equation.